Let me just briefly explain what you are going to be up against and what my expectations will be in this class. Math is all about, when it comes to unit circle, math is all about the Cartesian coordinate system. And so if there's a point somewhere in this grid, and I'm leaving it very generic on purpose, but let's say there's a point somewhere in this grid, and you want to identify the location of that point. You realize there's an ordered pair that would tell you the location of that point, correct? You know what I mean by that? Would you probably agree that it's something negative, comma, something positive, based on where it is? This is quadrant what? Thank you. And this one on the upper right? Bottom left? And lower right? Good, good, good. We're doing great so far. You may or may not know this, but there's more than one way to identify the location of that point. Let's say that point is -4, 8. Let's go 6 there. 4, 8. 4, 6. You can also identify that point by drawing a line from the origin and figuring out how long this line is. And if you're in pre-calc, figuring out what this angle is. That would also tell you where that particular point is in space. Now, have you guys learned this already, right? Is this something that you are familiar with or not? Some of you are. I'm seeing some of you aren't. Okay, so we are already finding the first disconnect here. This is the difference between rectangular and polar notation. This one is rectangular notation. We identify the point by doing a rectangular map to it, right? Walk out this many in this direction, walk out this many in this direction. It's like a treasure map, it gets you there. So I would tell you to go out -4 in one direction and +6 in the other, and that would get you to that point. Or I could tell you to stand in the center, turn whatever number of degrees this is, and then walk out whatever that distance r is. Both ways would get you to this point. Does that make sense so far? Here's the problem. In your pre-calc class, all angles are measured relative to the positive x-axis. Every one of them. Which is going to mean that you're going to become complacent, whether I want you to or not. And some of you already are complacent because you've been through pre-calc. And therefore, you believe that x is cosine and y is sine. It's something that becomes ingrained in you because of the unit circle. Here's why that's not going to work in this class. I will never measure an angle like this. This will make no sense for a physical world where things are happening. I would probably measure the angle from here. It would make more sense. That's the first problem. The second problem is the real world doesn't work this way. Generally, the positive x direction isn't 0. How many maps put upwards as north? All of them? I mean, every map on the northern hemisphere does. Southern hemisphere, maybe not. Northern hemisphere definitely does. And where or what direction is this? Thank you. Just checking. Do me a favor. Everybody point to the east right now. That's sad. It's that way for all of you that aren't pointing. It's where the sun's coming up. So could you point north real quick? Oh, nobody pointed up. That makes me so happy. I did the same thing in chemistry. Not the same. We got a lot of people pointing up in chemistry. So good job, everybody. Everybody pointed towards this wall. And yes, that would be the north. This angle right now represents a positive angle, right? If you guys have measured an angle this way, from the positive x direction, this would be a positive angle. The problem is that on a compass, north is 0 degrees, not positive x. And although this might be 90 degrees or pi over 2, depending on how you did your unit circle, east is considered 90 degrees on a compass. In the real world, we are not fixed in measuring our angles from the positive x direction and going counterclockwise. In the real world, things change all the time depending on the circumstance. So you need to learn a method for dealing with vectors that is, I would say more tactile, more visual, but more importantly, isn't always going to be the same. You have to be able to make and identify what you feel will be an appropriate angle and how you're going to measure that angle. And this is what we're up against, because in a few weeks, your pre-calculus class is going to change all that. And they're going to become fixated on the unit circle. And in that fixation, they're going to make the positive x direction 0, and all angles are positive if they're in the counterclockwise direction. You'll have to separate the two things, because we will not do anything like that in this class. So I want to start first reminding us that this whole thing is about stupid triangle. So I'm going to give you a method. I know we had started one towards the end of the class period yesterday. We're just going to start fresh because it's a fresh class. And I'm going to do two different examples. I have the numbers from yesterday. If you prefer, I use the numbers from yesterday, or I can start something fresh. Your call.
Where's the numbers from yesterday?
Sure. Give me the one that was on the left yesterday.
It was 12 meters, 25 meters, and you had to find the hypotenuse. And
There we go. In that angle, right? All right. I don't care whether you're good or bad at this. I'm giving you a procedure. You may do whatever you want, but Friday, get 100%. Fair enough? If on Friday you don't get 100%, you have to do it my way, and you have to show all your work. If on Friday you get 100%, I don't care how you do it. Is that a reasonable thing to do? So here we go. I am not going to write these steps down, but I would encourage you to. I also will remind you that you may have this piece of paper out on Friday. But the only thing that should appear on this piece of paper is the trig part. I'm going to tell you when we're leaving trig and going to our vector part, okay? So this part is just trig, and it's just fairly straightforward. I'm going to tell you what I want you to be able to do. Step 1, you have to identify on your triangle both the right angle and the angle of interest. Identify on your triangle the right angle and the angle of interest. Now, I want to be very clear. In the real world, when we're doing this, identifying the triangle isn't easy. It's not always easy to figure out where the triangle is, because I'm not going to present a triangle. You'll have to find the appropriate triangle. So I know that doesn't make any sense this minute, because right now there's a huge triangle on the board in front of you, but that's because I need to start with something very concrete. Our very next example, after we do the two that I gave you yesterday, will not be like this. You'll have to create the triangle from what you are given, and that's going to be slightly different than what we're doing right here. But identify the right angle of your triangle and the angle of interest. When I say angle of interest, which angle are you trying to find? Or which angle was given? That becomes your angle of interest. Because you need to know what side is the opposite side and what side is the adjacent side. And it's all labeled based on the angle of interest. So part 2, after you've identified the right angle and the angle of interest, label your sides. You know their names. So the opposite side is the one that is across from the angle of interest. The adjacent side is the one, of course, that is next to the angle of interest, that is not the hypotenuse, which is across from the right angle. So step 2 is label your 3 sides: opposite, adjacent, and hypotenuse. That part should be pretty straightforward. Three, and this is overkill, but I don't care. I want you to get these right. So this is overkill. Do this step first, especially if you can't do this right every time, or if you're particularly weak at this. Write out SOHCAHTOA. And I don't mean write out S-O-A, that whole thing. I mean write out SOHCAHTOA. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. Write it out. You'll notice I left a space. I want you to leave the space too. So step 3 is write out SOHCAHTOA. Step 4, fill in what you have. You will have things. Fill them in. So I'm going to start by noticing I have the opposite side. So everywhere I see the opposite side, I'm going to write 25. And everywhere I see adjacent, I'm going to write 12. So step 3, write out SOHCAHTOA. Step 4, fill in what you've been given. Step 5, you have to make a decision. You're either given a side length and an angle, or you're given 2 side lengths. The procedure will be more or less the same regardless, but you have to figure out which one of those you were given in order to proceed. In this example, we were given 2 side lengths. So because you're given 2 side lengths, that means what you have to do is a little bit different than if you're given an angle and a side length. So this is a branch in your set of steps. So in your set of steps now, this is step 1 if you're given 2 side lengths. So step 5 was you had to make a decision, which thing to do. So now we're going to the branching side where you're given 2 side lengths. So if you're given 2 side lengths, figure out the ratio you were given for the 2 side lengths, meaning find the decimal. In this case, I want 25 divided by 12. I don't have my calculator, but I'm going to provide it. So 25 divided by 12. Now I have 2.0833. And when you do this, 4 decimal places are better. And so at least 4 decimal places or better. The more you have here, the better. Now, if you have a ratio, and you have a ratio, what I want you to do is pretty straightforward, but this is the only time that you have to check to make sure your calculator is in degrees or radians. So it's at this moment that you make that decision. Do you want your answer to be in degrees, or do you want your answer to be in radians? And you choose whatever one you want to do here, but this is crucial. For me, it's always going to be degrees. But I don't know what your other teachers are going to do. But here's what I'd like you to do. Look at the trig function to which you have the ratio. We want to find out what angle goes with that ratio. So apparently there will be an angle that corresponds to 2.0833. So to find out what that is, you need to do the inverse of your trig function. So in this case, we're going to do the inverse tangent. So your step here, step number 2, after you've done your ratio, is do the inverse trig function that goes with your current ratio. Our current ratio is tangent. So do the inverse trig function that goes with your current ratio. So I'm going to hit second tan. I get 64.36 degrees. Now, once you find the angle that goes with your trig function, it's the angle that goes with all of the trig functions. So you'll notice I'm writing it in to all of the trig functions. So your next step, find the angle and write it in for all the trig functions. Now, I know you think we're done, but we haven't found the side length. And I told you we're going to do everything through trig. Now, I know you can use the Pythagorean theorem here, and I'm okay with you using the Pythagorean theorem. But what I said I was going to do is train you how to do this using trig, and that's what I'm doing. So I'm finishing this up. So in order to do this using nothing but trig, I want you to, on your next step, so this is step what, 4? Find the other 2 ratios, which means compute the sine of 64.36 and compute the cosine of 64.36. Find the other 2 ratios. So the sine, for me, is 0.9015. And the cosine is 0.4327. Now, you should be able to figure out the other side using one of the remaining ratios. That's your last step. Find the remaining side using one of the other remaining ratios. I'm going to use this ratio because I can. Now, I've done this twice this year. And you remember on your practice test, the practice math test, how I had this particular kind of thing on the practice math test? I want to know what the answer is. Show me that you can do this math and figure out what h is. I know some of you can't. That's why I'm asking. Take a minute and make sure. H has to be bigger than 12 or you're doing it wrong. Yep.
Whenever I plug in like 2.0833 like to the inverse of like 10, it's not working.
Are you sure? I'll ask you 3 questions first. Do you have your calculator in degrees? Okay. How many of you, is there anybody else that doesn't know how to put your calculator in degrees? Mode button? Are we talking about TIs? Are they TIs? Yeah, so hit mode, find where on the list the degree radians split is, go down to it, highlight the degree, hit enter. And then I think to get out of this, you hit clear.
You hit quit.
You hit quit, okay. Second quit, we'll get you out. All right, so to do it, and then put the number in. Does that make sense? And enter.
Oh no.
Okay. All right. Now, you guys have to understand something. Actually, you don't have to understand this. I'll just tell it to you. We've assumed for years that you guys already know how to do this, we physics teachers. And it's just recently in the last couple that you guys don't. I've always had to kind of reinforce it, but teaching it where you guys have very little skill set on it is different. So not used to that, to be honest, but you should never get these wrong because there's so many ways to check your work. Like right now, if you want to check your work, there's a method staring right at you. And I'm not sure if you see it, but you have another ratio that has been unused. If you want to make sure you're right, well, do 25 divided by 27 and see if it's 0.9. Because if it's not, you made a math mistake, and it's probably just arithmetic. But people make arithmetic mistakes all the time, and so this is a way to check your work. You could also check your work by just doing the Pythagorean theorem, which is completely not trig, but would be another way to check your work. There are so many ways to check your work that I would encourage you to understand that if you get these wrong, you've chosen not to check your work. And I'm telling you right now, you can have this set of notes out in front of you, and in these set of notes, you should tell yourself to check your work. On your last step, verify the last ratio works. If you turn your paper in and you didn't check it, come on. You really want to face me under those circumstances? Because I will probably say something. And it won't be nice. It's first period. I haven't had any coffee yet either. If this is our new one, again, you don't really need me for this, but I'd like you to identify the angle of interest and your right angle, label your sides, and then write out SOHCAHTOA. All right. You can go on to the next step because we're not at the branching step yet, which is to fill in what is known. We know the angle this time, so I'll fill in the angle. And we know the opposite side this time, so I'll fill in the opposite side. Okay. So now we reach the point where we're supposed to branch. We weren't given two sides, we were given a side and an angle. So if you're given a side and an angle, go to a different set of steps. It's not much different, but it's different enough. Where step one is make sure your calculator's in degrees. Notice, this, if you've done this right, you've had this written down twice. So if you're the idiot who put your calculator in radians on the first test, I'm gonna laugh a lot because you now had an opportunity to write it down twice, right? So you would definitely be trying to get it wrong if you didn't check. But the second thing I want you to do here is pretty straightforward. On this next step, compute all three ratios. Right? You have the angle. Just compute all three ratios. In the old days, I would give you guys a trig chart. I wouldn't let you use your calculator, but those days are long gone. So compute all three ratios. That means I'm going to do the sine of 37, and I get 0.6018. Again, I'd go out at least 4 places. Cosine 37, 0.7986. And tangent of 37, 0.7536. So we've computed our ratios, and you should have a pathway to solve for the missing sides, meaning it should be clear that 2 of the ratios will successfully give you the missing 2 sides. So I noticed that this ratio will give me the hypotenuse, and this ratio will give me the adjacent side. So your second to last step is to solve for the 2 missing sides using the 2 available ratios. So I will do that. And I'm going to do this for the student who needs it. I know they're out there. If you're that student, here's what you got to do. I'll multiply both sides by h. I'll cancel the h on the left side. I'll now divide both sides by 0.6018. And I'll now use my calculator. Of course, we're getting the adjacent side too. Now, your last step, check your work. You should have one ratio that you are unable to use. That ratio should be able to be used to figure out if your numbers are right. Right? The last ratio that's left is adjacent over hypotenuse. I just found the adjacent and the hypotenuse. If I take my 13.27 and divide by 16.6, it should equal 0.7986. It's not going to be perfect because you've rounded some of your numbers off, but it should be close. And that's how you can ensure that you can check your work. If it doesn't work out, the ratio is wrong, you've made a mistake. Somewhere there's an arithmetic mistake. All right. Label it according to general conventions. It will just be easier on you if you do. All right. Somebody pick a quadrant. I don't care. 1, 2, 3, or 4. 2. Done. So we want to find where this point is. That's what I want to find. To get to that point, I go out a distance 10 meters at an angle of 25 degrees. I want to find the x and y coordinate of that point. Okay. Does everybody understand what I'm asking about? That you're getting 2 numbers, the x and y components of the point. Now, look, there's some terminology here, and I want you to hear the terminology I'm going to start using today. This represents what's known as a vector. Remember we talked about what vectors were. They were values that had both magnitude and direction. This is a way of representing a vector. Generally, a vector is represented as an arrow, the length of which is the magnitude of the vector, and its direction can be indicated by using a coordinate system for reference. So this value represents a vector. I would like to find the components of that vector. The word component here is important. We'll be using the word component all year. Components are parts of a triangle that can define the vector. but they line up with an applied coordinate system. Components are parts of a triangle that define a vector, but they line up with an applied coordinate system. Do I have to say that 3 times? Components are the parts of a triangle that define a vector, but they line up with an applied coordinate system. For example, in the example I've drawn here, this direction could be north, this is west, this is east, and this is south. This might be a direction. I must go 10 meters, 25 degrees west of north. I could be telling you where something is. And that's exactly how I would say it. My vector is 10 meters, 25 degrees west of north. And I will expect that you guys can figure out how to draw this. Most students trip in the conversation about how to deal with west of north and north of west. So I'll tell you exactly what this means. 25 degrees west of north is spoken backwards. Because what it means is stand facing north, turn towards the west, 25 degrees. That's what it means to do. Stand towards the north, turn towards the west, 25 degrees. That's what this is telling you to do, but we say it as we are facing 25 degrees west of north. That's how it is phrased. So I will give you directions like this. Or the plane is diving at an angle of 30 degrees from the horizontal. Well, that would probably be, this way, 30 degrees from the horizontal. You have to interpret what you are given and place it on a coordinate system. Now, what I want are the components. I want how far a person would have to walk north, and then how far a person would have to walk west to get to the same point. Imagine there's a building in the way and you have to walk on the streets to get around the building. You're finding the components, the portions of the triangle that would lead to that point. So, the first step in solving problems like this is what I told you to do. Identify the triangle. You have to find a triangle that will get you to that point, a right triangle. And that triangle has to be lined up with your coordinate system. Some of you might know how to do this intuitively, and some of you probably don't. If you don't, listen closely to the following instruction and add it to your work there. You'll be given an angle. Wrap your triangle around the given angle. If you don't, you will screw this up. Because there are 2 possible triangles here, and most of you probably know this. You could draw your triangle like this, or you could draw your triangle like this. Right? Both triangles will get me to that point. One of those is right and one of those is wrong, even though the triangle lengths are exactly the same. Because one of them uses the 25 degrees correctly, and one of them doesn't. And although you could successfully use this triangle if you're careful and know how to deal with the angles, I promise you some of our problems will be more complicated, and you will have more success if you do this the way I tell you to do it, as opposed to the way you may want to do it. So I would always encourage you to wrap your triangle around the angle, meaning start your first side on the same side that the angle is measured. And then place your right angle off of your coordinate and outwards towards your point. Wrap your triangle around your angle. Now from there, you have to identify the hypotenuse, opposite side, and adjacent. This is an example of being given an angle and a side length, and your job is to figure out the opposite and adjacent side. Now, I believe you guys have the tool set to do that, and you have enough time to do that because we have a full class period. I don't think I should have to help you. So in a minute, I would like to ask 2 of you to tell me the opposite and adjacent side. Check your work. I'll give you a moment. All right, I'll take a volunteer. What do you got? Give me one of them, Amir.
The opposite is 5.735.
Who got 5.735? Yeah, I didn't either. But you said it with such confidence.
Can I tell you the adjacency that's right?
Sure?
8.191.
Nope.
But it checked out with my 35. Oh, I used 35 instead of 25.
There we go. Yes, sir?
Also I got 4.226.
Yep. Sergio, what'd you get?
Negative 4.22.
Negative 5. We're okay with, I would take either one at this point. And then who's got the adjacent side?
About 9.06.
9.06. All right, so that's it. So 4.22 and 9.06. I wrote those on the wrong one, so let me write them on the right one. So 4.22, 9.06. Now, for us, we're going to do something a little bit more than this. We have applied a coordinate system to this. And although I've labeled it northeast, south, and west, while you're working on a problem, I generally use X and Y. I want you to take what you have over here, your initial vector, and transform it into something in the X direction and something in the Y direction. You're gonna make a statement out of it. Now you'll notice I'm putting these little hats above the X and Y. Those hats tell me that it's in the X direction. You would say it just like that. So for example, this is negative 4.22 X hat, meaning I go negative 4.22 in the X direction. That's what the little hat on top of the X means, plus 9.06 Y hat. So that means 9.06 in the Y direction. Now, the reason why we have to learn how to do this is I'm going to be asking you to add and subtract and multiply and divide vectors together. And what you need to understand is that you can only operate on components of vectors. You can't operate on vectors directly. Meaning if you're asked to add two vectors together, you must first convert them to components. And then you can add X components together and Y components together. But you can't add two vectors together. For example, what if I gave another set of instructions to walk 5 meters at an angle of 30 degrees south of west? Well, where's my person now? Where'd they go? Now we know that they already walked 10 meters, 25 degrees west of north, but now they've walked somewhere in this direction. Now, if we start here, and they started facing west and turned towards the south 30 degrees, and then walked outwards 5 meters, they'd be here somewhere. If I want to find out where they are, there's only one way to do this. I have to take each of my vectors, break them up into X and Y, and then add those components together. So you have a job in front of you right now. I would like you to figure out the X and Y of my 5 meters, 30 degrees south of west. If this were me and I were new to this, and many of you are, I would consider avoiding distraction. Not all of you have to do this, but some of you do. And if you want to be successful, then please try and avoid distraction. Start fresh. That's west, that's north, that's south. Give yourself a fresh take. You don't have to draw it as big as I'm drawing it, but give yourself something that you can use that's less distracting. Now, for those of you who are not having trouble with this and you clicked it all together really fast, there's lots of shortcuts here. Use the shortcuts. They're fine. But for you guys who might need a little bit more time, avoid distraction. Now, we have 3 minutes. It's enough time. I'm going to tell you what to do as I do it. You guys should be doing it at the same time. I'm going to wrap a triangle around my angle. I'm going to identify my angle of interest and my right angle. I'm going to label the sides. I'm going to write out my sine, cosine, and tangent. I'm going to deal with my ratios. I'm going to compute my ratios. I'm going to calculate my missing sides. I'm going to check my work. And now I'm going to write it out. So I know some of you are still working, but I would like to reach a conclusion before the bell rings. I've now converted my vectors from what's called polar notation to rectangular notation. You can add like components together. So my 4.22 and my 4.33, that's negative 8.55 x hat. And 9.06 minus 2.5 is positive 6.56 y hat. This is the result. But generally, you now have to convert your result back to polar. So that means drawing a new triangle. This is the opposite of what we just did. But your set of steps should successfully help you figure out what to do. In this one, negative 8, positive 6, and then that's my result. Now we didn't finish, but we got really close. So